Okay, guys, so let's move on with our sliding door and take it a bit further. So, what should we do now? Well, let's try to make a double sliding door. We've already made our single sliding door, so let's move on to a next level of complexity. So, a door with either the overlap or both, where it's embedded into the wall and it comes out of the wall and comes together. Okay, so something like that. So we can use our sliding door blueprint that we've made as a reference. And by the way, an easier, more practical option would be adding a sliding door blueprint over here. And we can put one either side, right? So now we put one either side, we could make them wider so they fit into the door frame. And just make sure they're facing the right way round as well. Okay, so you can make them similar sizes and do it like that if you wanted to and just adjust the scale. Let me just do that now. Let's just adjust it like that, just so it fits in. A bit more. Okay, so let's check that out. There we go. So now we have our sliding door here, right? So let me just close this up a little bit. There we go. Now, if we run the blueprint, let's see what happens. Okay, so it's opening one of the doors and then the other when I go to the other overlap, right? So as you probably saw, you have to be in a certain place, almost like in the middle of the collisions for them both to activate. So let me just delete these now. And what we can do is we can add a door without the need to worry about mirroring. Okay, so I do it like this, and almost as if they're overlapping. So here I would have to reverse the side, wouldn't I? Reverse the slide and go to it. Okay, so that goes that way. If I come this side, it goes that way. So maybe I had it right before. Let's change it back. Okay. So let's suppose it's an overlapping door. We approach it. Now it's doing that. Okay, the collision box is a little too big, isn't it? Let's jump into it and adjust the size. Let's just reduce that one as well. Okay, let's try again. So if I come here, I'll open just one door. Or if I go to the other side, it will open the other door only. Okay, so this is an easy way to do it. But of course, as you expect, I'm going to show you another way that makes both doors work inside the same blueprint. So we don't have to use two, we can just use one. And by doing that, we'll be able to then increase our knowledge of how to do it properly. Okay, so let's do this. Let's create a single door inside the blueprint, a double door, but inside a single blueprint. So I'll use this as a base and just copy that and call it, give it a new name, maybe double sliding door. Okay, right. And double click it. Great. So there we have our old sliding door blueprint. First of all then, let's see what we need to adjust. So what would be, what's going to happen here? Let's think about it. Well, for example, we may have to, oh, sorry, let me just adjust this for now. Just line up. Okay, make it fit the door size. And make it a bit longer. Okay, so the character then can activate the door from a bigger distance as he approaches, right? It responds earlier. So what would be our workflow here? What were we trying to achieve? Well, using what we've already got in our blueprint, all of these elements should be useful to us. We should be able to use them, and we can make them move on the other side as well. So we can make like 2 doors work. So we might have to add a bigger collision, or maybe a duplicate collision to the other side. So let's see what we can do. We just rename the arrow to left, rename the door to left, and the box collision to left. And then if we duplicate all of them, just select them all, Control W, there we go. And now that we've duplicated them, we just need to rename them to be the ones on the right hand side. So arrow right, door right, and we'll get the collision changed as well to collision box, or box collision right. Perfect. So now we just need to place them in the right place. Just adjust the position. In fact, let's select everything and then move it over. That'll be easier. Okay. And that looks like we've got everything there. So let's rotate it so it opens the opposite way. Top view is always good to be able to do this accurately. So we rotate it 180 and just reposition it. There we go. And adjust the collision box to the center as well. And let's take a look at everything. So we can do it like this so it overlaps. That might look nicer. So it overlaps the other door. Cool. So we have a door that opens, is this door. This will open to the other side, and the other door will open to the other side. Okay, so let's do this. So this would be the blueprint for just the left side door. So we'll make the same blueprint for the right hand side. Okay, so how would we do that? Well, we can copy it and just change the necessary items. So I'll create both collision events here for the arrow and for the box collision. Okay, so when they overlap. So here I can just duplicate all of this and plug it here. And then we can connect them. That's reverse, remember? And the opening distance I need to rename to left. And I'll create another variable for the right hand side. Opening distance right. Oops. There we go. And make sure it's a float variable. And we need to compile it, don't we? So we can put in the value. There we go. So add a value of 100. And I'll replace it with the correct side, the right one. Okay, cool. And the target must be replaced here as well. So now we're using the right hand arrow. So we get that and put that in there. There we go. So this is our left hand side door blueprint, and this is our right hand side blueprint. And when the character walks towards the collision, they both should open up. And when they get to the other side, they should close, right? Cool. Let me just adjust one more thing. Let me just adjust this. It's 80. I think that's what we had before, but we'll be able to update it, of course. Okay, that's fine. Let's add this to the scene and then let's see what happens. Just need to rotate it into position. So, oh, there we go. Left is that way, and yeah, I think that's right. Let's just adjust it into the doorway using top view again to just line it up so it's just right. Okay. Cool. So that should be, in theory, that should be okay now. Now in our blueprint, the arrow is pointing the wrong way, isn't it? Now it's not going to make any difference to how the blueprint works, but if you wanted to, you could just adjust it. So we have a left hand side here, and it should move minus 80. So let's try it actually. Let's just see. Sorry, it should move that way as it's is it won't be embedded to the wall. So I'll use 80 as it was. As for this one, the vector was pointing there, right? So it would move at 82. Does that make sense? Well, let's go. Let's show it in practice what I mean. Let's see what happens as we approach. So it moves to the right. So this one worked. We just need to adjust the distance because it moved too far, didn't it? And that's easy to do now that we've made it visible, that we can edit it. Let's try 70 and see if it's enough. Just go up to it and there we go. Okay, maybe 65. I think that should work. Remembering that these distances are all centimeters that they're moving. Okay, so that's gone all the way to the end. Perfect. So it slid open and it closes. Cool. Now on the other side, we can see what's happening here. So it's going too far, isn't it? So there's a bit of a problem here. Let's see if we can work out how to fix this. So when I got to the door, it kind of got lost, didn't it? So let's just save first of all, and then we'll take a look. Okay, so what is it that could be going wrong here? Now, there is a detail that I was talking about earlier that's quite important for us, which is set relative location. So here we're adding an x coordinate, right? Because it's moving along that axis. But at the same time, we're telling the node of that y and z are 0. That's our starting point, okay? So why did it always work before? Well, we didn't need to change anything else before, did we? It was already set. So it was only ever going to move along the x-axis in our blueprint. So because it's not relative to the static mesh of our target, this causes a problem. So if you notice here, the other blueprints we've made, I'll just open a simple door just to show you. The simple sliding door blueprint, if you notice, I always add our arrow at the 0 point here, right? And this one as well. You see that? It's at point 0. So what happens then? Well, because I only wanted to change one dimension from one mesh, it was okay. I could put it as 0 and put that as a starting point and change it. And what's happening now is because we're using a duplicate of the arrow, we need to give it a different starting point. Okay, because we want it to, especially if we want it to open from a different angle. So we need to adjust the right hand arrow starting point. So just to be clear then, if I'm placing our arrow on the left hand side on coordinate 0, on the axis of 0, as soon as I click this event, as soon as it starts, it will position it at coordinate 0, okay? And for y and z, that will be 0 as well, right? So that's what happens for the left hand side. You can see that here. And whenever we go into the collision, the door's going to slide to the other side. It's going to jump, isn't it? Because it's going to think, right, I need to be over at position 0 in the world, and then I need to move. But that causes a problem because then we can't get in. So what do we need to do to solve all of this? Well, you've probably worked it out already, but if not, this is where another node comes in, which is really good. It's a really helpful node, specifically for rotations, okay? Because it usually moves on its axis, or if you don't add the arrow, for example, and the mesh axis in the right place, it will run, and it's easy to work this out. So it can help us out, okay? But working with placement is a bit harder as we have 3 coordinates. It needs initial starting point and ending starting point. So to get this working, we need to use a node called getLocation. And what does this do? Well, actually, what do I have to do is the better question. I need to tell the blueprint that the right-hand door has an initial position here in this location. So I have to tell Unreal that the right-hand side door is over this side, okay, or our arrow is over here. And there are 2 ways to do it. We can either type in the coordinates. I can tell it where it needs to go to, I can type in the coordinates in the timeline and add the coordinates and create a vector coordinate and then do the motion. Or I can ask Unreal to get the location, right? Sound good? So what would I have to do? Well, let's get that node called location. Let's type that in, location. And it's here at the bottom. It's called get relative location. And it'll pull out our coordinates as well, which is really good. So let me show you how this works with a print string. Let's get that print string. Okay, great. And plug it in. Great. So that's going to help us visually see what's going on. Let's press play. And if we get over to here, let's watch the screen. Right, you see that? So it's printed 137447. So let's add some more time on the screen, maybe 10 seconds, so we can see it for a bit longer. Let's go up to it again. There we go. So 137447, 2117 on Y, and 0 on Z. Got it? Did you remember it? Well, let's see. If I select this, look, 137447, 2117. Okay, so what's it done? It saved the relative position. So I have this relative position. What should I do next? Well, once we've got this information, which we're able to get because of the print string, once we've got this detail, I need to be able to sum up this position and the variation I want here. So let's suppose our position is 0, is 100 rather, and I want to move it 80. So I should do a sum of 80 from here and then 100. So what do I have to do? Well, let's add them all up. Let's do a bit of maths here. So sum up the initial coordinate and the increment, where it's moving, the value of the new position. Okay, so here I have a vector, right? And I have a single x coordinate. So let's just drag out from here, press add. And we've got our x coordinate over here. So do you remember this before with what we did with split struct pin? How we can put them back to how it was before. So we can do that. And then we'll be able to use a single vector. Okay, so let's just do that. Let's right click and there we go. It sends it back to how it was before, so we can use the vector. We plug that in. Great. So now, what now? Well, here I have a float variable that I can use, which is a single coordinate. So here I have 3. I can just split them up. And I can then connect that into the x coordinates. And then I'll get 3 coordinates from here, the x, y, and the z. Then when I tell it to get it, it gets all of those coordinates, all those positions. It adds them all up together and puts it into into this vector position here. Okay, so this is an option that will work, but I'm going to show you a new node, and hopefully a new node that you might decide to use as well. So you actually have it in your node's background, and it's always good to know more ways, isn't it, of doing things. So to do it this way, there's a node called make vector. So let's go and find that make vector. Okay, and we'll create that. Great. So now I'm creating a vector. I've added an x coordinate and it gives me a vector. Then you can just link this to here, right? Pretty cool and a lot easier. So we need to use only one coordinate here, x, and then 0 and 0. So that should help us. And then we plug that into here. And this is how the right-hand door is set up. So it should work. I've got our relative position. I've added how much we want to move it and added in our location. So let's see it in practice. Okay. Okay, so our door's open and it's gone for good. Well, at least it opened, but clearly it's gone too far. Now, let's see if we can fix this. Because that wasn't supposed to do it like that, was it? So let's see what we can do. Let's debug the error. Let's try to find out what's happening. Best way to do this is let's add in the print string. Take that off, and then now we've got a print string in. Actually, let's leave that in and put the print string here, just so it can show us the coordinates, so we can understand or try and understand it. Let's see it again. Let's approach the door. Okay, so now we can see where it's going. So it's going up to 3000. So something in X, even though we're set up at 80, why is it doing this? Okay, right. Well, it's updating it to this relative location all the time. And it's updating the position all the time. In fact, it's updating the position at each frame, and it updates it to our relative location. So every time this information is brought in, it gets this information, it processes it, and what happens then? Well, when I use get relative here, I'm getting the initial position of 0 times 0, but as soon as it increments 1, its position is already updated here. So when I move the element for a centimeter in increments, this too then ends up doubling or tripling in value, and it becomes an exponential scale. That is, it increases continuously. So what should we do here? Well, this is not the best place to look for this relative location, because it won't work out. It won't work out for us. But what should we do then? Well, we should get only the point's initial coordinate, not update it in real time. So let's change that. So what should I do now? Well, I need to get the coordinate only at the moment that the character steps into the overlap. So how do I do this? Well, there is a way of getting it the second we push play. When you push play, it will then store the coordinates. And this is really helpful because it will store the coordinate for the object that we want. So if at the beginning of the game, it's, for example, a begin play event, I'll create a begin play event, right? So I've created one here. And this event will run when I push play. So we need that. Great. So what do I want to do now? I want to get this coordinate, the coordinate of the right-hand side arrow. So I've got that now. I have an arrow right here. Only then will I get the location. So I get relative location. And now what's next? Well, I don't have the flow control. I have nothing really. What do I do now? I need to create a variable in which I can store this position. So I'll create a new helper variable to store this initial position. Okay, so let's create that together now. Let's jump over to here and create a new variable. And let me call initial position. Okay. And it's already made it a float. Great. Now, what I would want to do is I want to store a sort of vector information. So let's change the vector. There we go. Place it over here, and I'll press get or set. Well, I don't have this value yet, so I need to set it up. So I'll push get set and get the coordinate. Yeah, let's use set on this one. Plug this in, and it should get the initial position. There we go. I'll link them here. And when I push play, it will find this element in the scene, search its position, and then it will store it, okay, in this new variable that I've made. All right. Cool. So we saved everything now. So now we can keep what we had. But instead of getting the coordinates, here we're going to use this variable, initial position. And we'll plug that in there. So now it will get my initial coordinates. It won't keep updating it anymore like we had before. And when we press play, because it's locked here, it will be the position or the distance, okay, that it's just going to move it in a much better way. Let's see if it works. There we go. You see the coordinates now on the screen. So if you notice, it will come back also to its initial position when I move away, which was X137, I believe. And at the end, it's 217. So 80, difference of 80 there. And Y, you can see it's 0. It doesn't change, does it? Now there's just one detail that it's sliding to the wrong side. So let's correct that. And it's really simple to do. So we have our variable and we have to just change its distance here. We'll change that to minus 65. So let's see what happens now. There we go. Beautiful. And then this one moves to that side. Okay. Let's go around this way, see what happens. Okay, that works that way. So any side I walk into will work, right? Cool. So that's it, guys. Let's perform one last test. Let's suppose we want it to open from the center. Now that would be interesting. From the center and then open outwards. So we'd have to change the coordinates then, wouldn't we? We can do that. Let's change it here to 65 and also change the position of the box. So we would have to overlap these boxes, but I'll try and do this. Let's try and do this with the character. Let's have a look just so we can see what happens. There we go. So it slides open just as we wanted. Now, if I really want to do it this way, I can make a new blueprint, create a single box. I wouldn't really need two. Single collision. I wouldn't need to have two collisions. So instead of making a new timeline, we can just add it to the sequence that we have here. So we can connect it there and use this information. Okay. But obviously that's not our goal in this instance, but I just wanted to show you that's what you could do if you wanted to create the doors opening another way, and you wouldn't need to have two sets of overlaps. So when there's a single object, if you place its axis at 0, 0, 0, you don't need to worry about it really. But since we have more than one object here, we do need to think a bit more about it. Okay, so just as we've shown you here, using the initial coordinate is really helpful because it stores the information right at the beginning, stores its location, relative location information for us. And we don't end up with doors then flying off everywhere as we had in our previous example. Now, this also saves us having to create several different blueprints as well to store information. And we can just use it this way. So don't forget to add these comments around your blueprint. We've got our left-hand door and right-hand door, and this comment we could call get right door initial position. Cool. There we go. So now I know if I close this blueprint and open a new one, but I have to come back to it maybe later on, then I can see visually straight away what I've done in the setup of the blueprint. Okay. Now in the end, we have this blueprint. So we're starting to add a little bit more complexity to our blueprints, aren't we? So what next? Well, we'll move forward gradually. We won't go too far ahead, but you can hopefully really understand the concepts we're using. And when we start putting them into practice, then we start to learn even more. So when you start to replicate what we've done, you'll learn even more too. So I highly recommend you keep testing what I've shown you, keep practicing it, and think about how you would adapt what I've shown you here into your own personal project. So please keep doing some tests, because practicing these blueprints are what's going to help you really progress quickly. So let's finish now, and I'll see you in the next class.